Adaptation is about maintaining public service, managing our risks, avoiding costs of damage and disruption. It's also about helping Torontonians who are most vulnerable to extreme weather. This slide shows you that extreme weather events are on the rise, whereas geophysical hazards, shown in blue at the bottom, those hazards are staying about the same. So what I mean by that is volcanoes, earthquakes, tsunamis, they're staying about the same, whereas the weather-related disasters are increasing over time. In the period 1961 to 1990, Toronto averaged about 17 hot days. That is, days at 30 degrees Celsius or more. So you can see that by 2041, which is not that far off, the number of hot days is predicted to be more than double, and then almost double again by 2080. So by 2080, our climate might be more like North Carolina in terms of hot days. That's pretty shocking to think. Here's an example of what extreme weather can do in Toronto. In 1953, Toronto experienced the tail end of a hurricane called Hurricane Hazel, which caused dozens of deaths and massive property destruction. As a monument to that destructive event, this damaged bridge footing remains and reminds us why regulations now strictly limit the development inside the floodplain. And here's a close-up. You can see they've been able to transfer some of the newspaper headlines from the day of the event. So there are two main types of actions in response to climate change: mitigation, adaptation. That's the focus of my talk today. Mitigation involves reducing greenhouse gases. Adaptation involves proactive action and also seizing opportunities. Our infrastructure is already aging and is at further risk due to climate change and extreme weather in particular. Buildings, water pipes, sewers, roads and bridges, and the electrical system can be at risk. So when we have a hot day and the electricity system is highly under stress, that can be a time when we could have a blackout, and that's when people without air conditioning might be especially vulnerable. In addition to the cost of repairs and replacement of infrastructure, the impact on residents and businesses can be very significant. People without air conditioning and with pre-existing health issues can be at risk during prolonged heat events. On average, about 17 people per year die prematurely due to heat-related incidents. Hot days result in more smog. During the 2003 heat wave in Europe, there were tens of thousands of premature deaths. So I'm happy to say that public health has an extensive heat response program, which involves a variety of city agencies with staff redeployed to seek out and help vulnerable people. Now, there's also a lot of impacts on natural systems. The top one is a Culex pipiens mosquito. That's the type of mosquito that carries the West Nile virus. On the bottom right, you have the black-legged tick. That carries Lyme disease. And on the bottom left is the emerald ash borer. So the emerald ash borer is an insect that is killing off our ash trees. Well, essentially, these invasive species have more breeding cycles if they have a longer chance to live. So if winter comes late, they may be able to get an additional breeding cycle in, and this increases their populations. Yes, this is Toronto, and so is this, Bathurst and Steeles to be exact, on August 19th, 2005. Some neighborhoods are more affected than others, and there's two reasons they might be affected more than others. And it's funny, we may have extreme rain in one spot, but nothing too much in another. And then another issue on why some neighborhoods may be affected more than others is that they may have a soup bowl effect where you've got a lower lying area and the sewers were simply not designed to carry that much water. Now, if you're driving along and you see a big sinkhole in front of you, you might not want to drive over it because you might have something coming up like this. Always a bad idea to be driving through deep water because this might happen. Complete collapse of the Finch Avenue arterial. This road was out of service for 14 months. To just give you a sense of the cost within a 3-hour storm where there was 6 inches of rain in some areas. The total cost was $547 million. About half of that was paid out by the insurance industry for basement flooding. and the other half was for commercial payouts having to do with flooding of automobiles or business disruption. TTC underground bus loading areas and also subways are at risk in the case of extreme rain. Indeed, Toronto is taking action, and I mentioned our climate change adaptation strategy ahead of the storm. It was unanimously adopted by City Council in 2008. The strategy identified short-term actions and also the need for risk assessments to identify and prioritize longer-term actions. Two major parts of this work were local level climate modeling and also the development of this risk tool. The tool has been piloted in our roads department or transportation services. I want to give you a sense of the level of detail of this risk assessment that was done for transportation services. This is what runs the traffic signals, okay? Now, as we looked into the detail, we identified that some of the older model traffic controllers were actually failing in extreme heat conditions, so they're overheating. And so the staff said, well, in that case, you know, we're going to have havoc if we have these things failing. And so we've got the new units that have a fan, but on top of that, we said, well, sometimes that fan actually fails. We're now adding a maintenance inspection of that fan. So that's the kind of work that city staff do to keep our city running in the face of climate change. The roads risk assessment identified culverts as a significant risk area. This is a picture of a culvert, and it shows that we've got some trees that have fallen into the stream and water has washed the trees close to the mouth of the culvert. And so city staff have identified this and they'll be cleaning it up shortly. But this is an example of how a culvert could fail. So we've got 154 major ones and thousands of small ones. So this is the kind of thing where these culverts were not designed for really, really big storms, and it's essential that they be maintained. You can see that the top of it has actually been bent down, so there may be a repair issue there as well. We've also got waterways. This happens to be the Lower Don River, and that's the Richmond Street Bridge going over it. In the case of heavy rains, and especially when the lake level is high, the water can actually flood over the road and cause problems to traffic. Now I've got a red arrow. It's pointing to a bridge abutment, okay? So that's the part that holds up the bridge. And I'm gonna look in a little bit closer, but from the side. What you can see there is a lot of tree wood debris that has started to build up around there. And so staff monitor the level of debris there, and once it's getting to a level that it needs to be cleaned out, heavy equipment is brought in. So again, this is an example of the work that needs to be done. And if this is not well maintained, what can happen is that can break loose and then could then further go downstream and cause problems such as blocking the flow of low slung bridges. So here's a good example of forward planning for climate change. Just west of that picture that I just showed you, it's a large earthen berm in the circled area, and it's constructed to protect the area west of the Don River from flooding. This berm has been designed to withstand greater than a 250-year storm. So this is forward planning. So if you ever drive by there and you're wondering, why have they built that big hill there? Well, it's to protect the downtown. If that hill was not there, then we are literally looking at the possibility of Union Station having water pour down the steps. Toronto and most other cities across North America have major infrastructure deficits. This means that investment in infrastructure maintenance, renewal, and construction has been deferred for many, many years. Here's an example. This is the storm sewer grate from 1889. Its relatively small drainage holes make it just a bit more vulnerable to being plugged. So if a plastic bag, a whole bunch of leaves got across there, there's just a little bit greater chance of that being plugged and the water not draining properly. Action is being taken by Toronto Water, big time. This is an underground stormwater storage tank under construction at Old Shepherd Avenue. The large stormwater holding tank will help reduce basement flooding in the Pleasant View neighborhood of Toronto. So that's a huge project. In fact, this is one of the very biggest projects that is on the go at this time. Toronto's largest climate change adaptation program is the Basement Flood Relief Program, which began in 2006. The 2012 recommended budget includes $743 million in investment over 10 years from 2012 to 2021. Also, since 2003, Toronto has been implementing the Wet Weather Flow Master Plan, and this involves $1 billion investment over 25 years. Toronto has an objective of increasing the tree canopy by 50%. Now that's a very aggressive target, taking into account we've got invasive pests, we've got extreme weather, and also we've got urbanization. On the issue of roads and climate change adaptation, the tower on the right is a road weather information system tower. And what this does is it takes weather measurements right on the spot, and we have these deployed at various parts across the city. So the information about wind speed, temperature, precipitation is detected and then sent back to the central control yards, and those people deploy salt trucks like the one on the top. Now that's a 3-in-1 truck. It actually can apply brine or salt and brine or just salt. And that gives the city crews a much more versatile approach to being able to look after issues of icing on the roads. Also, the trucks have sensors that indicate the actual temperature of the road. And then you'd think, well, what's a street sweeper got to do with climate change adaptation? Well, the new street sweepers can actually operate without water. And so that means it can be cold and no snow, but have a dirty road, and you can still run it. Residential flood protection is a significant area that we're trying to promote across the city. Property owners might find success in reducing water damage to buildings by regrading their lot, taking into account the drainage requirements of their neighbors. So you don't want to regrade and then cause a trouble for someone else in your neighbor next door. You want to grade it so the water is going to a place that is not causing problems. On the right-hand side of the bottom, you can see a sewer backflow prevention valve, and this helps reduce the chances of sewer backup. Green roofs is another initiative. These are primarily helpful in cooling a building. They also can help retain a little bit of the runoff. Permeable pavement is also an area that's helpful if there's a part of our city where there's a lot of runoff and causing problems. By allowing the water to infiltrate on the spot in a parking lot, it can be worthwhile using this type of technology. We formed a group known as the WeatherWise Partnership. It has 60 members from various sectors, including banking, insurance, telecommunications, commercial and residential real estate, transportation, and communications. All 3 orders of government are also involved. Our main project this year is quite innovative. We're setting up a climate change vulnerability assessment for the electrical supply system of the entire Toronto region. And that was decided just last week. The group plans a summit within about a year from now to report back on the results. In closing, I think that this is a very positive example of the multi-sectoral cooperation that is needed to make cities more resilient to extreme weather and to help ensure our continued prosperity. Thank you very much.